last page. So we've got ourselves a reaction here. This is a Voltaic cell reaction. Let's do it. Let's figure out what happens here. So we've got zinc and copper sulfate react to give copper metal, copper solid, and zinc sulfate. Just off the bat, you can even see that this is single replacing another single atom. So this is single replacement, which is an answer for later on. So this is a single replacement reaction. Sure, it's a redox, but it is, when asking about reaction type, we're talking about single replacement, double replacement, all that stuff, okay? All right, let's find the oxidation numbers. Let's get going. First things first, zinc metal by itself is 0, okay? Now over here, we don't know the charge of copper, so let's break it apart into its ions. What is the charge of sulfate? Looking at the book, sorry, the periodic table, it's -2. So copper has to be what? +2, okay? So once we know that, the oxidation for copper, +2, all right? You could solve the, let's do it, let's solve all of the oxidation numbers for the ion. You can do it up here, but let's do it down here. So if we have SO4, 2-, we know that oxygen is -2, and since there's 4 of them, it's -8. What number does sulfur have to be to give us a leftover of -2? +5. Okay, so sulfur is +5, oxygen is -2. +5, -2. And let's just double check if you want. Do I know how to count? Yes, no, I don't. +6. Okay. I always have to double check because I get confused if I don't watch myself. Okay. -4 times -4 times -2, that's -8. We have +6 and +2. That's all 0, so that's perfect. Okay. Now we have copper metal, which is a metal by itself, not an ion, so it's 0. Same thing with zinc and sulfate. Just to figure out the charge of zinc, we'll break it apart. We know that SO4 is 2-, and zinc has to be 1 to balance it, +2. So they're similar ions. So this is +2. The cool thing is, once you find sulfur and oxygen, if they stay together, the oxidation number is the same. So this has to be +6, and this is -2. So we're in good shape. Okay, excellent. So now let's figure out who's getting oxidized and who's getting reduced. All right, take a look at it. Switch to green. All right, here we go. Zinc here. It is becoming positive, so it's less negative. So it's losing electrons. Zinc is losing electrons, so that's oxidation, right? All right, let's look at oxygen here. It stays the same, nothing going on with the oxygen. Sulfur stays the same, very nice. Copper, +2, which is 0. Copper, it looks like it's gaining electrons. To get rid of that +2 charge. So that's gaining electrons reduction. Okay, all right, now that we have that, let's think about who the oxidizing agent is and who's the reducing agent. So zinc undergoes oxidation. Who's causing the oxidation? This one, because this is the one that is losing electrons. This is copper is taking electrons. So you could say here the oxidizing agent is copper or copper sulfate. Oxidizing agent. Okay, you can say it's copper or copper sulfate. Both are fine. Really, it's the copper because it's gaining the electrons. But if you said copper sulfate, that's fine. Now, let's take a look at this. If this is undergoing reduction, who's causing the reduction? Where is it gaining? Where is it taking the electrons from? From zinc. So this is the reducing agent. It's just the opposite, really. Right? If you're undergoing oxidation, you're the reducing agent, vice versa. That works when there's two things going on. So there's the story so far. Zinc is losing electrons. It's becoming to Zn2+. And those electrons are going to Cu2+ and becoming Cu. Right? So if this one's losing electrons, this one's gaining electrons, could you imagine separating them with a wire to get them to do work for you? Yeah, make a Voltaic cell. Let's do the half reactions. Look, we just break it in half. The zinc loses 2 electrons to form Zn2+. How did I know there were 2 electrons? Well, look, it's +2, so it's got to go from 0 to +2. So I know that I'm losing electrons. Zinc goes to zinc 2+ and 2 electrons. It's a product. That's why it's on the right side. Okay, watch out and see here where they are. Copper is copper 2+, and it becomes copper. So there it is. Copper 2+ plus 2 electrons becomes Cu. There you go. Let's make a Voltaic cell. Since we know zinc is losing electrons, we'll put it on this side. On the negative side, the anode. Okay? And then over here on the positive side, the cathode. Okay? Remember, on the cathode, undergoes reduction because there's a red cat. And remember, there's Redox. This is oxidation. And that's the loss of electrons is oxidation. Gain of electrons is reduction. Okay? So electrons are coming out here on this side. The drawing already has the electrons, so you know that zinc has to be here. And it gives its electrons up. As it gives its electrons up, it creates zinc ions. So this thing, you'll see it's getting smaller and smaller. If we actually did the Voltaic cells overnight, we would actually see that our electrodes would be small if they're the same level. So zinc going to zinc ions. Okay. So the electrons are traveling over here, and really they're going to the copper ions, so the copper plus the 2 electrons, to make zinc metal. So this side is, copper metal, so that side's getting better. The cathode, it's gaining electrons here. Okay. Now this reaction only works, as we found in the lab, when you have a salt bridge. And this is potassium nitrate. We use potassium chloride. Usually you pick an ionic compound that doesn't form precipitates, solid precipitates. Nitrates and potassium ions don't like to precipitate, so we use those. Okay. Now, as we're creating more Zn2+, we need to balance out the +2 charge with something. So what it is that we need to balance out the +2 with something that's negative. So this is usually like a tube or a paper towel soaked in the liquid. The nitrate can go and balance out the more +2. If not, the solution starts getting positive, and it won't like to do that. So the zinc will not break off to form that. So you need to balance it out. Try it. Take away the salt bridge, it doesn't work. Over here, we're losing plus charges, so we need some plus charges to balance it out. So the potassium of the potassium nitrate goes over here. I mean, really, when you think of potassium nitrate, it should be aqueous anyway into the K+ ions and NO3 anions. And those are the folks that balance out the missing plus and the negative balances on that. Okay. So if you put it together, you put some zinc, you connected a wire to a light bulb, you connected the salt bridge, you had zinc, probably zinc sulfate or zinc nitrate solution here, and copper sulfate or copper nitrate, and get the reaction going, you should have a light bulb going on, or at least a voltage, depending on the voltage difference. We'll find out. I don't think we'll be doing it this trimester, but in Chem 2, you'll learn that depending on what metals you use, they have a higher voltage difference in their reaction. So some of them give a lot of electrons, some of them a little bit. In the lab, you'll see that some of them only gave off a light when connected in series, where you could build up the voltage. Okay. Other ones, they just did it right off. Things like lithium batteries in your computer and things, they have a very high voltage difference, so they can create a lot of electricity